Hey guys, welcome to Bug Lover 27, and dear gosh, it's been way too long since my last video. So on that note, let's go. For today, we are going to be talking about math. Again, hear me out. The subjects today are going to be absolute value equations, functions, relations, domain, range, absolute value functions, and finally piecewise functions. A lot to cover in one video, so let's get cracking. First, we're going to talk about what absolute values are. You've probably already seen them before. They're kind of famous in the math world. Boom, here it is. Let me explain a little bit about it further. Essentially, absolute value is expressing the number of units that it'll take for a number to get to 0 on a number line. For example, let's say we have the absolute value of 2. It'll take 2 units to get to 0. Now, let's say you have negative 2. It would still be 2 because you're taking 2 units to get to 0. Make sense? Let's try to solve this one to dip our toes in the water. This is going to be similar to solving any normal equation, but also slightly different. Instead of having only one answer, there's going to be 2. So let's get to work. First, let's take away those walls. Now we have a simple negative 6x equals 42. Let's work on this one first. We do negative 6 divided by 6 on both sides. Now we have an even 7 equaling x. Let's do the same thing, but make it a positive 6x equals 42. Divide 6 on both sides, and now it's negative 7. That happens. All right? Easy. Now, let's do one that's a little more complicated. Let's take care of this giant monster. Well, it's not really a monster. It's more of a lizard. Let me show you by taking it apart one step at a time. First, we need to get the absolute value alone. So to do that, we will subtract 10 on both sides, making the equation this. Do plus 2 on both sides, making the equation now here. Now you know the drill, divide 6 onto both sides, and then finally, your answer is 2 equals b. Now remember, we aren't done yet. We still have to do the other equation. Now, this new equation is going to be the absolute value of negative 6b minus 2 minus 10 equals 20. And voila! Everything's going to be the same process-wise, and you'll arrive at your answer, which is 1.33 equals b. On a little side note, if your answer is ever negative, that means there is no answer. What do I mean? Well, let's say you have an equation like this. You don't even have to try to solve it because it's unsolvable. Anytime you see this in front of a number, just don't try to solve it. Just write unsolvable or DNE. That means does not exist. Let's do one more for good measure, but this time you will do it on your own. Here's the question, and pause the video if you need more time. Now that we have that out of the way, let's go to our next topic. Functions, relations, range, and domain. Oh, don't worry, it's not nearly as hard as the other topic. Promise. To start off, let's figure out what the heck functions and relations are. To simplify the answer, they're kind of the same thing, both of them involving points on a graph anyway. But there's one key difference. Relations would be something like this, or this, while functions would be these guys here. What's the difference between them, you may ask? Well, imagine you have a Pokemon, and its name was Calcu. Its first form would be a relation. Then the final evolution would be a function. How it evolves is that it passes a test, a very simple one. We call it the vertical line test. As the name suggests, we're going to be placing a vertical line and then see if it strikes through the relation once. If it does, then congratulations, it's evolved. But if it strikes more than once, then it stays as a relation. That's cool. Relations are cool, but I'll stick with my function. Now that we have that down, let's talk about domain and range, because it's a little trickier. So the domain is how wide the function or relation is. So let's say we have this function here. We're wanting to know from here to here how big it is. While we could be boring and count each unit, we could also do this. Boom. Now, what did I just do? I found the smallest unit that is here and found the biggest unit that is here. Then in between, we're going to be looking for x. And I put that here because, of course, the biggest unit is going to be eaten by the crocodiles. But how did you determine which one has the line? That is also very easy. See that open dot? It means that it's super close, but not exactly on the point. So it won't have a line under it. And if it's a closed dot, like here, it'll have a line underneath it because it means that the point is on it. Good? Good. Now the range is the opposite, meaning how tall is it? Now you would normally go from the lowest point to the highest point like this. But what if it's infinite? It's okay. It's not really that hard. Boop. Look. Just place an infinity. Alright. Let's give you one to try. And then we can go over it together. So, what's the domain? Range. Is it a function or relation? I'll give you a second. Pause the video if you need more time. Here we are. Here are the points for the domain, range, and when we do our test, it passed. Makes sense? Great. Next lesson. Absolute value functions. If you guys are wanting to color, get ready because we are going to do that soon. This part of the lesson is going to be how to apply the last two lessons onto a graph. Let me explain. First, we need to know what the equation means. So let's say you have this equation here. You're going to make sure that the point is up 5 units on your y-axis. And same thing if you have a -5, you will just go down 5 units. So what if you have just this? Would you move it to the right 7 units on the x-axis? No, actually you don't. You would move it to the left on the x-axis 7 units. What if you had -7? Would you still move it to the left? You probably figured me out. No, you don't. Just remember it as the signs mean the opposite of what it says. I know it's weird, but that's how it is. So, let's put it in a whole equation. Let's figure out what this will be. Now, beautiful, we have our points. Now what? Let's add another aspect to the equation, the slope. It's the easiest part since it actually says what it means. So if we just add a 1/3 in front of the equation, now we have practically everything we need. Practically. Remember, I did promise you I would let you all color. So let's get going. Our equation is now this. So let's add a crocodile to that equation. Remember from the last unit that the no line under the crocodile means that it's not a solid? The same thing here. The line would be dotted as you make it. Now it's color time. Now, in this case, you would be coloring the bottom since the crocodile is pointing this way. I'll give you a minute to try another one. Pause the video if you need more time. So it's basically saying we're going to start at the -5 point and make it a closed dot. Then we're going to go to infinity on the other direction because it's infinity. See? Giant monster mama is just a baby lizard mama. Let me give you another one to try out for yourselves and then we can come back together. Alright, cool beans, let's look at the answer. Wow, that was super intense, but we made it through on the other side relatively unscathed. If you have any questions, let me know down in the comment box below. And remember to leave a like and subscribe so that you can see the next time I make a video like this one. Until next time, I'm BugLover27. Have a nice day.